Hi everyone, we're going to find the slope of the tangent line to the graph of f at a this one is g in this case, of a given function, g, at a given point, and this is our point. So the first thing I'm going to do is write my limit as delta x approaches 0, and we know that that's going to be g of x plus delta x minus g of x over delta x. That's the formula. In this case, my x is 1. So what I'm going to do is I'm going to erase these x's and put a 1 in there. So this is just going to be 1 and 1. And now I'm going to write down my function g and input this and subtract. So we're going to do the limit as delta x approaches 0. And I'm going to write down this function and input g of that, which is 1 plus delta x minus g of 1. Well, g of 1 is right here. It's already given to you at -3. So that's going to be -3. Or you could actually plug it in here and get it again. All over delta x. So what you're going to get here is limit as x approaches 0. And I'm going to FOIL that out. 1 plus 2 delta x plus delta x squared minus 4, and then that's going to be plus 3 all over delta x. And clean that up. This equals -1. So these two cancel. And we're just left with 2 delta x plus delta x squared. And what I want to do is going to put the delta x under each piece. So we have, this should be delta x here. Okay, and then this is going to leave you 2 plus delta x. And then when you plug in 0, what we're going to get is 2. So the slope of the tangent line to the graph at a given point on this one is 2. And we're going a little faster on the next ones. They're all very similar. So we want the slope to be at this point for this equation. So we're going to do the limit as delta x approaches 0 of g of 2 plus delta x minus g of 2 all over delta x, which is the limit as delta x approaches 0 of g. So we're going to get 5 minus, I'm inputting this, my x, which would be 2 plus delta x, and then we have to put the squared, minus g of 2 happens to be 1, or you could plug that in. So basically, we have delta x, and then what we want to do is clean this up. So this is going to be 5 minus 4. If I FOIL this out here, this is 4 plus 4 delta x plus delta x squared. That's this piece. So it's 5 minus all of this. So everything turns negative. Minus 4 delta x minus delta x squared minus 1. And then you clean all that up. 5 minus 4 is 1, and that cancels with that. So we're left with 4, negative 4 minus delta x. Oh, this was all over delta x. And when you plug in 0 into this, our answer is going to be negative 4. Okay, we're going to do another one here. So the point is 0, 0, and we have the limit as x, delta t this time, approaches 0 of f of 0 plus delta t minus f of 0 all over delta t. So then we're going to get the limit as delta t approaches 0, and everywhere there's a t, I'm going to plug this in. So basically this just equals what? Delta t. So it makes it easier. So we have 3 times delta t minus delta t squared, and f of 0 is just 0, so it's just going to be minus 0 over delta t. And if I divide both of these pieces, you get the limit as delta t approaches 0 of 3 minus delta t. And when you plug in the 0, you get 3. And this should have been a t here. And then I have one more. Okay, so this one, the slope's at negative 2, 7. So we have the limit as delta t, again, I hate the t's, approaches 0. It's h function, so we have h. My x is negative 2 minus h of negative 2 all over delta t. And then we have the limit as delta t approaches 0. And you just plug everything in. So we have negative 2 plus delta t squared plus 3. I just wrote him down and plugged in this into the t. Then subtract your h of negative 2. H of negative 2 is 7 all over delta t. And then you simplify. You're going to get the limit as delta t approaches 0. And this is going to be 4 minus 4 delta t plus delta t squared minus 4 all over delta t. These cancel here, and you always should be left with just delta t, the change in t on this. Now we have the limit, this is all equals, the limit as delta t approaches 0, and if you divide both of these by delta t, you get negative 4 plus delta t. And so when you plug in your 0 here, you're going to get negative 4. And that's the slope of the tangent line. Real quick, we're going to do two that are linear. So if we have a linear 3 minus 2x, and we want it to be at the point negative 1, 5, and we also have another one. We have g of x equals 3x, 3/2 x plus 1, and we want that to be the slope at negative 2, negative 2. Whenever these are linear, all you have to do is take the slope, because this is a line. So the slope of the tangent line is just negative 2 here, and the slope of the tangent line here is just 3/2. That way you don't have to go through that whole process. Thank you. Have a nice day. Bye-bye.